Hello Prep 3. Our session today about mirrors. Let's complete our lesson. Firstly, start with the two laws of light reflection. There are two laws of light reflection. The first law said the angle of incidence equal the angle of reflection, means they are directly proportional, means when the angle of incidence, for example 10, the angle of reflection equals 10, 20, 20, 30, 30, 40, 40, 0, 0. The second one, the incident light ray and the reflected light ray and the normal line all are in the same plane which perpendicular to the reflecting surface. This is the second law. So the first law, the angle of incidence equal angle of reflection. The second one, the incident light ray and the reflected light ray and the normal line all in the same plane which perpendicular to the reflecting surface. Next, here what's meant by the incident light ray? This is the light ray that falls on the reflecting surface or that falls on a mirror. The reflected light ray, it is the opposite. It is the light ray that returns back or bounces back from the reflecting surface or the mirror. Then the angle of incidence, it is the angle between incident light ray and the normal line. And angle of reflection, it is the angle between the reflected light ray and the normal line. We have important question here. Give reason. When the light ray falls perpendicular, it reflects in itself. As you can see here in the figure, in this one here. When light ray falls perpendicular, it reflects in itself. Because the angle of incidence equal the angle of reflection equals 0. We can see the angle of incidence here, means the angle of incidence equals 0. And according to the first law, also the angle of reflection equals 0 also, because both of them are equal. Next, what is meant by the angle of reflection? As an example here, angle of reflection equals 40. Here write the definition of the angle of reflection. It means that the angle between the reflected light ray and the normal line equals 40. Let's go to the important part here. What are the properties of the image formed by a plane mirror? There are 60 properties, which is very, very important. Number 1, upright or erect. The second one, equal in size. The third one, laterally inverted or reversed. And the fourth one, which is virtual. Virtual here, not real, means cannot be received on a screen. Give reason here why the image that formed by a plane mirror is virtual. Because it cannot be received on a screen. Number 5, the distance between the object and the mirror equal the distance between the image and a mirror. For example, if you stand in front of a plane mirror at a distance 4 meters, so the distance between the mirror and your image also 4 meters. So the distance between you and your image equals 8 meters. The last one, which is number 6 here, there is a straight line that join between the object and the image. This straight line is perpendicular to the reflecting surface or a mirror. Here a very important give reason also, the word ambulance here is written in converted way in the car. Why? To appear in front in the plane mirror, okay, in front of the in the front car, okay, can read it in a correct way. Now go to the second part or the second type of mirrors. We call it a spherical mirror. Spherical here means a part of a sphere or a part of hollow sphere, a part of circle. So spherical, it is a mirror whose reflecting surface is a part of hollow sphere. Maybe concave mirror or converging mirror or convex or diverging. What is the difference? If the reflecting surface is the inner surface, we call it concave. Again, if the inner surface, we call it concave. If its reflecting surface is the outer surface, we call it convex. So the concave mirror, it is the mirror where its reflecting surface is the inner surface of a sphere, while convex mirror, it is the mirror where its reflecting surface is the outer surface of a sphere. Another part of the comparison between them, concave mirror, we call it converge mirror. Why? Because it collects light rays, while the convex mirror diverge light rays, means disperse them away from each other, so they are opposite. The next one give reason here why the stainless steel spoon at home considered as a spherical mirror. When you go home, go to the kitchen and look at your face in the stainless steel spoon. Okay, you find the inner surface acts as a concave mirror, while the outer surface acts as a convex mirror. You can see here, look at this picture, you can easily differentiate between them. This one here, a concave mirror, okay, your image is small and inverted, while this one, the outer surface of it is as a convex mirror. You can find your face large and upright. Now we have some concepts, some definitions which are very important in this lesson according to the spherical mirror. Number one, we call it center of curvature. Center of curvature, we said that concave mirror or convex is a spherical mirror. Spherical means a part of sphere, a part of whole sphere. Any whole sphere, any circle, any ball contains center. The center of this sphere, we call it center of curvature, which is C. So the center of a sphere, it is the center of a sphere, the definition here. It is the center of a sphere, that is the mirror is a part of it. The second one, radius. Radius in math, okay, to the distance between center and any point, and here also the same. What's mean by radius of curvature? Or it is the distance between. What's mean by it? It is the distance between center of curvature and any point in a mirror. So we have only one center of curvature, and we have many radius. Okay, we have uncountable number. Not only one radius. If you join any number, any line, between center and any point in a mirror, we call it radius. The second one or the third one or the next, we call it pole, which is P. P means here it is the point in the middle of reflecting surface of a mirror. For example, this mirror here may be, for example, say 10 centimeter, in the middle 5. So you put point in this middle here, in the middle at 5 centimeter, this point we call it pole. So pole is the point that in the middle of reflecting surface of a mirror. We have a straight line which is very important, we call it a principal axis. A principal axis is the straight line that passes through center of curvature and pole. Again, it's very important, not the distance between them. No, the distance between the center of curvature and pole, we call it radius. But in a straight line that come from anywhere then passes center of curvature and passes the pole, we call it a principal axis. And we have only one principal axis, by the way. What is the next one? After center of curvature, we have secondary axis. Secondary axis, any straight line that passes center of curvature and any point in a mirror, except pole. Means, as you can see here, we have two secondary axes. This one here moves down and the other one moves up. We have many, uncountable number of secondary axes. Now to differentiate between a principal axis and secondary axis. The principal axis is only one that passes center of curvature and pole. Only one. While secondary axis, any straight line that passes center of curvature and any point in a mirror except pole. So we have only one principal axis and uncountable number of secondary axes. The next concept, we call it focus. Focus means here, we use this meaning or this concept in our daily life. For example, focus in this point means concentrate, means pay attention. So the focus here is nearly the same. Focus of the mirror, which is F capital letter. As you can see here, many rays, all of them falls in a mirror and reflects back. When they reflect back, they meet or collect together at one point. This point we call it focus. So focus here is the point of collection of reflected light rays. As you can see here, it's only one point, we call it focus. Now the distance between this focus and pole here, we call it focal length. Focal length, it is the distance between focus and pole. And this distance, by the way, equal the distance between focus and center. Concentrate please in this point. The distance between center of curvature and pole, we call it radius. And the distance between pole and focus, we call it focal length. And the distance between pole and focus equal the distance between focus and center of curvature. So we can say here that the focal length equals half radius, or we can say it by other way, the radius equals double or twice the focal length, because the distances are equal. The distance between P and F equal the distance between F and C. Again, focal length equals half radius, or radius equals double or twice the focal length. Here the direction of reflected light rays. Reflected light rays. We have it three ways. When the rays falls in a mirror, passes by three ways only. Number one, when the incident light ray falls parallel, or when the incident light ray falls passing focus, or when the incident light ray passes center of curvature. We have it three ways. What will happen to each one of them? Number one, when the incident light ray falls parallel to the principal axis, it falls in a mirror and reflects, but reflect passing through the focus. The second one, it is the opposite. When the incident light ray falls in a mirror passing through the focus, which is F, it falls in a mirror and reflects, but parallel to the principal axis. The third one, when the incident light ray passes center of curvature, C, it reflects on itself. Again, there are three ways of rays. Number one, when it falls parallel to the principal axis, reflect passing through focus. When it falls passing focus, reflects parallel to the principal axis. This one. The third one, when it falls in a mirror, passes center of curvature, it reflects on itself. And the third one here give reason why. Because angle of incidence equal angle of reflection equal 0. Thanks a lot, my dear students, and see you in the next time, inshallah. Thanks a lot.